Hi, my name is Claire Arthurs, and we're going to find the Taylor series of f of x equals 2 to the x at a equals 1. So before we begin this math problem, we have to know what a Taylor series is. So the definition of a Taylor series is the summation of f of n, we take the nth derivative of our function, multiply that by x minus a to the nth power all over n factorial. So that's going to give you the following. So the first term would be f of a plus the first derivative of a times x minus a plus the second derivative of a times x minus a to the first squared all over 2 factorial. And so that goes on forever and ever. And the final term would be as follows. But it would theoretically go on forever. And so when we find these series, the first step is to take some derivatives of our function. So our function is 2 to the x. I mean, you can't really take the derivative of that directly, so how would you do it? First off, we know that the number 2 just equals e to the ln of 2. So that'll as follows: 2 to the x equals e raised to the x ln 2 power. And then we also know that the derivative of e to the x equals itself, e to the x. So using the chain rule, we can find that the derivative of e to the x ln of 2 equals ln 2 times e to the x ln 2, which equals ln of 2 times 2 to the x. And so taking some derivatives, we have the first derivative equals, just the function equals 2 to the x, and we need that for the first term up here. And so the first derivative is 2 to the x ln of 2, so that's used in the second term. And then the second derivative is 2 to the x times ln of 2 squared, and that would be used for this term over here. And it goes on, and we want to do a few of these derivatives so that we can develop a pattern. And so the next step is to sub in a equals 1. And so when we do that, we find that 2 to the x goes away and just becomes 2. And then the rest of the terms remain the same. And so now, as we want to develop this pattern, we want to substitute it in for that format. So we know that the first term is 2, second term 2 ln of 2 times x minus 1 plus 2 times ln of 2 to the squared times x minus 2 squared all over 2. And then the next term, 2 ln of 2 cubed, x minus 1 cubed all over 2 factorial. And that goes on and on and on. And so now we want to develop a pattern so that we can put it in this format, so we can find the actual Taylor series. Because, as we know, this goes on forever, and we want to put it in one statement. So we notice that the 2 remains constant in each term, so we keep that. And then the ln of 2 is continually raised to a power, and that increases. And x minus 1 does the same, and as does the factorials. So, as follows, the summation is 2 to the times ln of 2 to the nth power all over, or times x minus 1 to the nth power all over n factorial. And that's how you solve the problem. Thank you.